Hello, this is the course review video of ENGR 586 Robot Modeling and Control course. Besides the control part of the robot, we have studied 7 chapters. In chapter 1, it was the introductory chapter, and in this chapter, the definition of robot and the laws of robotics are covered, along with the major areas and the whole overview of this course. Later in chapter 2, the description of position and orientation is covered. In description part, the position can be expressed by a 3 into 1 vector, and we have learned that orientation can be expressed in 3 into 3 matrix, and frame is the combination of position and orientation. One of the most fundamental topic I have learned in this course is the rotation matrix. And other than this, we have studied operators and homogeneous transformation matrix, which is also one of the most fundamental part in this course. We also studied representation of orientation, like the xyz fixed angle and Euler angle combination, like xyz zyx. In chapter 3, forward kinematics of manipulators, the topic covered are mutual perpendicular twist angles, link offset joint angles. These are the fundamental basics of forward kinematics, and using these basics we actually developed a table which is called DH parameter, and later on we write the transformation matrix from this DH parameter. In chapter 4, inverse kinematics of manipulators, the problems are like the transformation matrix are normally given, and we have to find the joint angles theta 1, theta 2, theta 3, etc. And we have learned two methods to find out these joint angles. One method is algebraic method and another one is geometric method. And beside this method, we actually learned a bit about workspace. Later in chapter 5, the velocities and static forces, we studied linear and angular velocities, and we studied one of the most important topic of this course is called Jacobians. And using this Jacobian, we actually calculated linear and angular velocities, and also like static forces. In chapter 6, the dynamics, the linear and angular acceleration is covered, and we actually learned a method called velocity propagation method from link to link. And in chapter 6, the Newton's equation and Euler's equation is also reviewed, and from Newton's equation we actually learned how to calculate force and torque acting on a link. And we also learned the iterative method of Newton and Euler dynamic algorithm to find out this omega dot, and later we have learned how to find out this torque and force. At last, in chapter 7, the trajectory generation, we have learned different points like starting point, end point, via point, different. And besides, in trajectory generation, we actually learned a method cubic polynomial for paths, and we have learned it for some general cases with via point and without via point. And at the end of this course, we actually learned another method like linear function with parabolic blend. We actually uh, did it for trajectory with a linear function with two parabolic blends. Thank you so much. And I would like to thank you, Dr. Meheran Shirelji, for his continuous support and on and off the class. And thank you so much.